This is a walkthrough of the group quiz for integrated 2. Thanks for being here. You're being given an equation in intercept form. We're going to standard form. You did this with box method, most likely, way back. So you set it up with a box. X times x is x squared minus dos x. 6 times x gets you 6x. This concludes with minus 12. We're combined in the middle. So x squared kicks it off with plus 4x, and then minus 12 rounds it out. So now going to vertex form. Interestingly enough, I kind of want to speak more on this intercept form because this is also telling me a few things that might help us out, like that the one x-intercept is at 6, 0. And where do you think the other x-intercept is going to be? Hopefully you're saying -6, opposites of this, even though we should set it up and solve accordingly. This one's a pretty light factor. So this is saying our x-intercept's -6. So how does that help us? Visually, we now have an x-intercept at 2 and another at -6. Let's do a quick visual of this. So this distance here, what's this distance from here to here? Hopefully you're saying that there's a distance of 8. So we want to split that so that it's 4 on each side. So let's do 1, 2, 3, 4. So this is saying we have distance of 4 on the left and to the right. So our axis of symmetry is halfway between -6 and +2. So it's got to be at -2. So how does that help us with vertex form? We can now say that we have parentheses, x opposite of -2, so x plus 2 being squared. But we need our y coordinate, so this is a pretty simple plug and chug. So we're plug and chug. So we have plugging in -2 for x, -2 minus 2 parentheses, and then multiplying with -2 plus 6. That's -4. This is +4. So this helps because now we can feel pretty confident that our y coordinate for the vertex is -16. So that just drops there. We can also now conclude that our vertex is at -2, comma, -16. That's part 1. What questions you got? Type them out. You've definitely factored something like this before. Factors of 9 that add up to 6, 3, and 3. So this expanded is x plus 3, x plus 3. We can also say pretty confidently we have just one x-intercept. So just one of these at -3, 0. We can also, interestingly enough, feel pretty confident that this is where the vertex is, because if we map this out, one x-intercept at -3 goes up from there. So this means that we have an axis of symmetry there at -3, and this is also our vertex in disguise. Nothing too crazy here. This is I wouldn't say a rare condition of one x-intercept, but it does happen, so there it is. Interestingly enough, can we agree, hopefully, this is x plus 3 2 times? So we're allowed to actually say, in a weird way, this can be considered our vertex form. And I guess for those that need to see that y coordinate, you could write +0, but this is a little just extra. Like, do you really need to write that? I don't think you have to. And maybe one of the transformations you make note of is that this looks as if it went to the left 3 units. So that's problem 2. Questions, type them out. Standard form, we did this prior to the quiz. I made a note to highlight this part and then distribute a 3 around there. So this, for the starters, should be 3 parentheses x squared minus 8x plus 16, and minus 12 is following that up. You can distribute, continue that, 3 x squared, 3 times negative 8 is negative 24x, plus 48. Don't forget the minus 12. So combine like terms from here, 3x squared minus 24x plus 36. Factored form, let's see if this is possible. Interestingly enough, these are all divisible by 3, so you could kick out a 3, get this, and then notice I just took out a GCF of 3 from all 3 terms. This can be factored further to 3x minus 6, x plus minus 2. So we're in pretty good shape. Here you could say that the leading A term is 3. You have x-intercepts at 6, 0, 2, 0. Quick visual of that. You have an x-intercept at 6 and also 2. You're splitting this. So where do you think that's going to be? Hopefully you're saying x equals 4. And then interestingly enough, the vertex, we could have gotten this immediately because this was given to us in vertex form. So x coordinate's 4. The y coordinate for the vertex is there, is negative 12. I don't even have to plug in. Feeling pretty confident on that. Questions, type them out. Here, a little wordy, but the main song and dance is factor and see what x-intercepts you're working with. Noticing you have a 10 here and a 40 here. This is negative, so I'm feeling pretty confident that taking out a negative 10 is a good move. And what else could be taken out? What do you think? Hopefully you're saying that they both have variables, so you can take out the lowest version, which in this case is just p to the first power. So this should now leave you with variable, then notice opposites here, negative 10p going to positive 40. This has to deduct 4. So interestingly enough, this is saying that we have an x-intercept of 0 and also at 4. And this opens downwards. So this means that our cutting halfway is going to be at 2. So what does this mean? Take a price that maximizes the revenue is that $2. This is pretty much saying what's the y coordinate. So plug and chug to get a hold of that. I'll just plug into the factored form. So that's plugging in where p is 2. So negative 10 times 2 is negative 20. 2 minus 4 is negative 2. So this is saying that our max revenue, pretty much the vertex, is at $40. Ticket prices where revenue is 0, that occurred here and here at $0 and $4. I guess $4, not quite in the budget, doing too much. It's okay. For vertex form, you already know that it occurs at 2, so you can lock that in, say that it's p minus 2. Your A term here can be reused as negative 10, and then the y coordinate of your vertex can be pushed into here as plus 40. And giving respect to the original equation, call it R of P. Questions on this last problem, type them out. Thank you for taking notes on this. See you soon.